Good afternoon. Good afternoon, class. So I'm going to show you guys how to introduce you to actually using TI Tina. So go ahead and open up TI Tina. There's a tutorial on how to install it, at least for the Mac. Let me pull up the lab. So I should have done that before the video, but that's okay. So let's look at Lab 5 really quick. So in the pre-lab for Lab 5, okay, so, oh, this should be a 4. Okay. Okay, in the pre-lab for Lab 5, you are asked to basically simulate 6 logic gates. Well, technically 7, but I don't have the 7th one drawn. You're asked to simulate an inverter, NOR gate, a NAND gate, OR gate, an AND gate, and an XOR gate. So let's go ahead and start with a simple inverter. So to find a inverter, the parts that you're using for the inverter are the SN7404, 7404. If we click on this little arrow, this little hand pointing at this basically says find components. If we type in SN7404 and hit search, it'll pop up a component. So if we say insert, it'll pop up one inverter. Now this is a hex inverter, so we technically have 6. So I'm going to first remove this. So the reason I'm going to first remove this is I'm going to put down my I'm going to make my waveforms first. So go ahead and grab a ground. So let's drop the ground over here. Then the next thing we're going to do is we're going to add the 5-volt supply that needs to go to each of the components. So it's already at 5 volts, so that's okay. It says VS, yeah, so that's fine. Press OK. And then what we need to do is we're going to add, we're going to add a jumper. I'm going to rotate it a little bit to the left. So I kind of use the jumpers to represent like ground and VDD. So I'm going to rename this jumper. So go ahead and right click on it, go to Properties, and I'm going to call this VCC. Okay? And then now what I usually do is if you right click, go to Properties, this is ground 1. Usually I just change this to ground. That's just me. So if I drop down a if I drop down a inverter like so, and I go to and right click on it and go to properties, you'll see ground. So type in GND, and for VCC type in VCC. So this is basically your supply and this is your ground. If you click on these arrows, it'll just show it, but you don't need to. But the neat thing is once you've done that, so let me go ahead and save this. Lab 5, let's do logic live example. Okay. So now if I go up to this arrow to add another component, and if I go to this inverter and add it, and I insert it again, if I go to properties, it'll actually have these already connected, which is nice. So let me delete that. Now if you go ahead and copy this, the problem with the Mac is you can't really directly copy because you're running it through a Windows emulator. So I haven't actually figured out a workaround for that. So like for Mac users, you basically have to go, like if you highlight it, I think you have to go like edit, copy, and then you got to go edit, paste, but it doesn't do it right. So you can't actually copy the circuit. Anyways, let me show you guys how to simulate this. Okay, so the next thing we need to add is we need to add a clock. The reason I add a clock is you can generate a digital high and low. So what we're going to do is we're going to add a voltage generator. So go ahead and click on the symbol that says voltage generator. I'm not going to attach it directly to the inverter. There's a reason why I'm doing that. So let's go ahead and move the inverter over here. And then I'm going to move the names just a little closer to the supplies. And then I'm going to wire these right here. And then I'm going to just draw a wire that goes up like this. And then I'm going to draw another wire here that goes to nowhere. So if I right click on the wire and go to properties, you can create basically kind of like a net name. So I'm going to call it net A, and I'll show it. And if I go over here and right click on this and go to properties, make sure show ID is showing. And now basically those two are wired. I'm going to put the inverter up here. Now what I'm going to do now is I'm going to get a voltage meter, and I am going to wire these guys like so. Now I probably should have left the ground. So if I go to properties here, this is ground 1. So now the problem is if I want these to be connected, I have to rename that. For me, I don't like having things named ground 1, but that's just me, so you guys can leave it like that. Or another thing that you can do is you can actually leave the name alone and you can create a jumper and call it ground. That works as well. So if I go and I right click on the voltage, the waveform generator, what we need to do is if you go and click on the signal, you'll see little 3 dots that generate. Go ahead and click on that. What we want is we want a square wave, and I forget what frequency I asked for, but let's go ahead and do 50 Hertz, and you can leave the rise and fall time, but the amplitude, let's create the amplitude at 2.5 volts. The reason why we're doing 2.5, the amplitude is actually half the peak to peak. So right now it's from minus 2.5 to plus 2.5. But what we can do is we can introduce a DC offset in order to make it actually a square wave. So let's introduce a 2.5 DC offset and press OK. Now we actually have enough to start simulating. So let's see, I think let's do transient simulation. And then what we can do is we can do I think 25 milliseconds. And you can do calculate operating point, but let's do use 0 initial values. Press OK. Oh, okay, let me fix that really quick. So in order to fix that error, 2 warnings, we will fix that. But as you can see, this right here is our inverter. So let's go ahead and rename that. So we can double click on it, and let's just call this INV out. Okay. So let me fix that jumper problem. So go ahead and drop down a jumper, and go to properties and call this ground. And I think this will work. So now if we simulate it, analyze transient, and run it. So, yep, okay, so now it's working just fine. So I think one of the problems is it's looking for a ground for the inverter, and so it's looking for a jumper. So anyways, that works. So now in order to do the simulation for other parts, see now the name's inverter out, and this is VG1. You can come here and rename this. So we'll call this slow clock. Okay. So now what we need to do is I'm going to drag this ground jumper out a little bit so I can put down another clock. The reason why we need another clock is we need to be able to go through the different logic combinations for the other gates. So once again, grab a voltage generator and go ahead and drop it down. Go ahead and wire it up. I'm going to drag the name a little closer. Oops. Drag just the name. Okay. Draw a little line here. Right click. I'm going to call this one B. Press OK. Now I'm going to right click on this guy, go to properties. I'm going to call this fast clock. And then it already has a DC offset, but the one thing we need, so it has a DC offset, which is good, but we need to change this to square. We need to change this to an amplitude of 2.5, and we need to change the frequency to 100, so twice the frequency. Press OK. Press OK. So let's go ahead and save this, and let's just go ahead and run it. So now we should see our fast and slow clock and the output from the inverter. So let's go ahead and run transient analysis again. Press OK, and it should be okay. So we got fast clock, we got slow clock, and we got inverter out. Now I think if I delete inverter out and put it down again, I think it'll rearrange it. So delete that. So let's go ahead and put another voltage source here. Oh, sorry, voltage meter. And then I'm just going to rename this, hold on a sec, so I can just drop down grounds without having to worry. So press OK, and we're going to connect the ground. So if we go to the properties of this, it's ground 1, that's OK, go ahead and save it. And we're going to change this to inverter out again. So let's see, transient analysis, let's go ahead and run that. Still giving me 3 warnings, but that's okay. Okay, I didn't switch it up. Oh, I guess it does. Okay, anyways, there's a slow clock, fast clock, but okay, that was just me experimenting. So anyways, to add another part, what you do is you go back to here. We're going to cheat a little because the next part we need is, let's get, I think a NOR gate is a 7402. So go ahead and search for that. And yep, it is the NOR gate. So let's drop down the NOR gate. Now if you double click on it, or right click, go to properties, you need to change ground to GND. Now that's connecting to this jumper, so that's fine. And then VCC, which is connecting to that jumper, press OK. Okay, and then all you have to do is we just need to add a little wire here, little wire here, and then what we do, right click, go to properties, go type A, and right click on the one below it, go to properties, type B. So now these two, let's go ahead and save it, these two wires at nodes 2 and 3 of this NOR gate are connected to A and B. Now I could have wired it, but now it looks quite nice this way. So if I go to a voltmeter, go ahead and drop down the voltmeter, and we wire it up. Let's get a ground again. Let's wire up this right here, and double click on the voltmeter, change the voltmeter to NOR out. Let's go ahead and save, analysis, transient, and run. There's some other tools that you can use under analysis that another student pointed out to me, which is pretty cool. So now that I put down a NOR gate, remember the inverter just inverts whatever, so the slow clock, see it's high here and it's inverted here. It's low here, so the input to the inverter is low and the output of the inverter is high. Now in the case of the NOR, NOR is looking at fast clock and slow clock. So basically NOR is the opposite of OR. So OR is going to be 1 whenever you have a 1 into A or B, but if you have 2 zeros or 2 falses into an OR gate, it is a 0. So a NOR gate, when you have 2 zeros, is going to generate a 1. So basically, if you look at fast clock, it's 1 here, it's 1 here. So it's true and true. So NOR is 0, which is right. Here it's false and true, but you have 1 true, so once again it's false. Now again you have 1 true, and then you have a false here, but you still got a true, so basically this right here is false, and then you have 0 and 0 here, and this is true. So this is how you start to begin to simulate as far as with transient analysis. There's a couple other little neat little tools that you can use under and I haven't messed with them too much, but under T and M, you have a function generator, multimeter, you got some oscilloscopes and stuff like that, which is pretty cool. So you can actually interact with your circuit. Um, let me pull up the, where did the multimeter go? Oops. Oh, there it goes. Okay. Give me my multimeter back. Okay, it's not showing the multimeter. Okay, let me just see if it'll bring it up. Oh, okay, let me drag this out of the way. Yeah, there we go. Okay. It's really annoying when things pop up behind. Okay, so I think, let's see how this works. So we'll measure a DC voltage. So NOR out plus, oh, okay, so NOR out plus. Okay, so basically, these are basically your two voltage nodes here that you can measure. And then the low we want to put to ground. And the only thing though is this is kind of what the steady state. So I think you have to implement some switches and stuff like that. So we won't do, well, I guess we could try that. Okay, let me try doing that. I think if we put down a switch, no, I better not do that. But anyways, if I want to add the last part, the NAND gate, all you do is once again is you click over here and you change this to 0. You search, say insert, and so I'm going to insert the NAND gate here. Go ahead and double click on it and change this to ground and VCC. Press OK. And once again, if you're using Windows, you can copy and paste the 2 lines above, but I'm not using Windows, so I have to draw these all in. So right click on this, go to properties, name this A. Right click on this, go to properties, name this B, and then bring down another voltmeter, drop down to ground, wire this up like so. Double click on the voltmeter, change this to NAND out, press OK. And now if we simulate this, it would go analysis transient, press OK. The results will now show, well, once it's done simulating, should show the NAND out, which it does. So in the case of an AND gate, when you have two ones, you have a 1 here and a 1 here, you have a logic 1 out, but NAND is inverted, so basically you get 0 here and then you get 1s the rest of the time. So if I wanted to make a AND gate, what I can do is I can insert apart the inverter, which is the 7404. Go ahead and insert that. Now if we insert it over, well, insert a little far. If I double click on this right here, you'll notice it's already connected to the supplies, which is good. So now all you need to do is wire it up like so, and then add another voltmeter. Oops, what did I do? Because it was, oops. That's interesting. It doesn't. Hold on a sec. Okay. Oh, there's a graphics bug there. Huh. Okay, I don't like that. So let's drag. Oops. Okay, come on. Function control Z. Yeah, there we go. Let me highlight this. Okay. Let me delete that. And then let's hook up the inverter. Okay, there we go. So that's a little weird graphics bug. So I will drag it down so I avoid that in the future if I wanted to add more onto it. Oh, you're not going to behave. Okay, there we go. And then I'm just going to draw this to the same ground, and then I'm going to change this to and out. Okay, so now if I simulate this, analysis, transient, now we should be able to see NAND, AND, NOR, and the inverter. So you should simulate all the gates and get an idea of how it behaves, but as you can see right here with the AND gate, when fast clock and slow clock are 1, you get a 1, and the rest of the time you get a 0, which is the opposite of this. Now if you go to show and hide curves, you can just hide the NOR inverter, and then I think you can rearrange these. Let's see. Nope, not there. Anyways, so now we're just looking at the AND and NAND gate. So as you can see, these guys are the inverse of each other, as they should be. Anyways.